Hello, and welcome to Basic ChIMP Electronics Part 2. And we're going to be taking a look at the hoverboard motors. So the hoverboard motors have three phases. There's slightly heavier wires you can see here. And there's three phases that I have extended to silicone wires for the run up to the O-drive board. So I've just literally wrapped, soldered them, and then heat shrinked over them. And then there are 5 wires that come out of the Hall effect sensors from each in each one of these motors. And there's a red and a black, and those are for the power. But you have to extend those wires, and also due to the fact that you can incur some signal problems with this run, we've gone ahead and designed a PC board, a little tiny PC board that has the necessary 22 nanofarad capacitors to ground to help eliminate the noise problems. And we're going to be installing that length of cable with the board attached onto each one of the Hall effect sensors and everything else. So there you can see we've attached a black wire. That happens to be the negative or ground going into the Hall effect sensor. And I'm doing the same thing I did with the power wires, just in miniature. Each one of them is wrapped, soldered, and then heat shrink tubing is pulled over it and heated with a hot air gun, not, if you can help it, with a lighter. These are very fine wires. I think the wires that I'm using to extend are 22, and the wires coming out are 22 gauge, and the wires coming out of the motor are actually 26, I believe. So here you can see me heating up the heat shrink and shrinking it down. And it's the same way, like I said before, that I did the phase wire. But this, plus the little printed circuit board we've developed, should keep the signals pure, and the O-drive will work properly. So we have to mark each motor. There's the O-drive motors at designations are M0 and M1. And we just want to make sure that we've got them when we pull them through the tubing on the other end, that the right one stays with the right encoder or Hall effect sensor board and the right 3 phases of the motor. So I'm marking both the phase wires and the Hall encoder wires with little stick-ons. You can just use masking tape or however you want to do it. And then when we actually pull each one, we're going to wrap them all together in temporary electrical tape, just to make them easier to pull. But there you go. We've got 2 little flags that both read M1. And we'll do the exact same thing on the other motor. See, M1 is the right-hand motor, or the ChIMP's right-hand motor. And M2 is the left-hand motor. And so, M0 is the left-hand motor. And so we'll be marking them as such. Now, I've just fit the 3D printed motor adapter. Once again, if you don't have a 3D printer, we'll see if we can't find somebody that can hook you up. The STLs are available on our website. So I've inserted this little metal thing I made out of a coat hanger into the hole. And when I feed these wires all down there, I'll be able to pull them out the center axle. And there's one. Just that simple. And you don't have to, there's the actual little tool made out of a coat hanger. You don't have to push this all the way in right now. But the seam in the adapter should be vertical. In other words, you can see where the outlet is for the wires. That's vertical. The seam should be running up and down there. Now I flipped it over. I've got the second set of wires. This is for the other motor. I'll feed that down. The tool's in place. You don't want to feed it all the way past the hole, but you want to come close so that then you can pull this wire and pull them all out. There you go. That's pretty simple. And when you get this one down, once again, the seam should be vertical. We'll just feed that in. And then it's super simple to push down, and the whole thing collapses, and it's perfect. Later, these motors will be pinned in place. The motor holders or adapters will be pinned in place with a single set screw on each one of them. So now I'm feeding them down. The tool's in place again, and the ChIMP is upside down. and gravity does its work, and there you go. How simple was that? Now all those wires come into the area where the O drive board is, and this is the connections to the O drive. On this, I've connected the blue, yellow, and green wires in a row, and I follow that same thing on both of them, blue, yellow, and green. And then you can see I've also plugged in the encoder boards for the Hall effect sensors. Now I'm adding the power wires that we've previously pulled down there. There's the black one on the ground of the J2 jumper, and here comes the 5-volt. That's the actual wires that power everything above. So I've got them on 5-volt and ground, black on ground, white on 5-volt. And this is the UART connections that go up and speak to the Arduino. And in that case, we have the blue going into GPIO pin 1, and this is on the J3 connector, and the gray on GPIO 2. And now I'm using this incredible black hot glue gun. And believe me, this really helps. So all the connections here I've hot glued. They're kind of permanent, and this will keep them from coming out. You don't have to apply much hot glue at all, but this stuff is wonderful, and it will keep your wires from popping out. You know there's going to be some crashes, and you can use that hot glue on any connection up above where the Arduino is or anything else if you're afraid that something could come out. Now remember, use the Fritzing wiring diagram that's in with the instructions, and follow it as closely as you possibly can. If you have any questions, please ask on the forum. We're here to help you. That concludes the basic electronic wiring. All right, we're on to programming and testing. This is going to be fun.